In 2016, Maverick Applied Science developed the Plant Engineers FRP Forum to create a platform where plant engineers could come together for in-depth discussions and to improve their work and knowledge of non-metallic piping and equipment. After the success of the initial Plant Engineers Forum, Maverick decided to offer this training yearly. The third annual Maverick Applied Science FRP Plant Engineers Forum was held on May 9th and 10th, 2018. This year's forum included presentations by key Maverick employees, along with a broad group of industry leaders. This year's topics included what proper non-metallic equipment purchasing specifications should include, how to choose the proper materials and manufacturing methods, how to design internal structures, and how to choose the correct codes and standards for fabrication of your non-metallic equipment. Finally, we also included some inspections of non-metallic equipment. Since everyone was not able to attend this forum, Maverick would like to share some of the offered presentations to the public. Thank you for your interest in Maverick Applied Science.
So I'm going to stimulate all of you guys with a discussion on veils. Not much for reinforcements. Tom kind of covered that yesterday. So we'll talk a little bit more about veils. So taking a step back too, it's important to realize, we have everybody, some people didn't even know what FRP meant, stood for. They came here, fiberglass reinforced plastic, so now you know, versus people that have been in the industry for 30 years, and we have fabricators. We have a little bit of everybody, so it's good to take a little bit of a step back and understand that, let's break it down piece by piece so we can just kind of hammer down these kind of main points. So that's where we're going to try and talk just a little bit more about veils, and hopefully there's something to learn for everybody, because there's things that I learned while putting this together. So just a little bit of background. So veils, we've said it before, but worth reiterating. The innermost surface in contact with the fluid. Veils are very, very thin, paper thin. About 10 mil, 10.01 inches. So something very, very thin is very, very important for the overall life of your component. Important to keep in mind, though, that the selection of these veils is an evolving concern and process. What was selected or recommended 10, 15 years ago might not be the same recommendation today, so it's important to keep testing. There are resin companies, glass companies, they keep testing. It was mentioned yesterday about the C581 testing, the coupon testing. So those tests are being done constantly to determine what are the best veils for certain chemical services. So subtle or seemingly minor process changes. So something to keep in mind. Don't select the veil just because you have hydrochloric in your process. What other elements can sneak into that process? If it's just hydrochloric, okay. But if there are different elements in there, we have to be worried about the trace elements, what you can't see necessarily, or what you don't expect, not necessarily what you do expect. So we're going to kind of compile all of these, kind of our knowledge, we're reaching out to different people for their knowledge and experience, and we kind of compile this so we just have one set presentation topic where we can just talk about veils and see what we have as of today. So like I said, just basically the purpose of the surfacing veils. So glass can be corroded. Okay, we have ECR glass, which is supposed to be more corrosion resistant, but the resin itself is what provides the corrosion resistance. The glass is in there to give us a strength and stiffness, so we're not cracking, gives us a little more strength, a little bit more comparable to a steel material in that case. So you're asking, why don't we just do all resin? Well, if you just did 100% resin and you have any kind of bending, it's kind of like, I would say concrete is a decent example, where you have the cement and you have the rebar inside the concrete. So the rebar is kind of the glass holding everything together. If you didn't have the rebar in there, then it's very weak in certain loading conditions. Same thing with resin. Chop strand mat, so corrosion barrier, we go veil, mat, typically, or 2 veils, 2 mats, something like that. The mat's pretty strong, but it's not as corrosion resistant, doesn't hold as much resin. So a mat is about 30% glass, 70% resin, where a veil is about 10% glass, 90% resin. So something so thin matters so much for the life of your part. So when you get through the veil, And through the 90% resin, now you're getting into the chop strand mats, which are now 70% resin. So now the permeation, the corrosion, and the life is going to decrease kind of at a different rate once it gets through the veil. So I won't dwell much on these since we've talked about veils a couple times in some previous presentations yesterday, but the C veil, most common veil available currently. The C stands for chemical grade. It's good for acids. It's good for bases. Not every base. There are certain places where C veil just doesn't work very well. C veil's very common because it's good and it's easy to work with. You also have ECR veil, which is a little bit less common, but a little bit more on the same line of using a C veil, where you can decide to use an ECR veil. ECR it's for electrical and then corrosion resistant. So you see ECR more with glass, so in a chop strand mat or your filament windings. But they also make ECR veil that has certain uses too. It's just not as common as C veil nowadays. Nexus veil is a more synthetic veil. There's no glass in here. This is generally used in situations that the fluid attacks the glass. There are certain chemicals that just eat up glass, so you use a synthetic polyester material. Nexus holds a lot of resin, so sometimes people think, well, I'll just double up veils or go 3 or 4 veils on top of each other and get extreme corrosion resistance. Well, Nexus holds a lot of resin. On the right there are 2 different styles, non-apertured and apertured. Most commonly you'll see people using apertured. It's a little bit easier to wet out, but regardless, Nexus is pretty tough to work with, and it holds a lot of resin, and it's important to really saturate both sides of the Nexus with resin so you get full saturation and no pitting. And lastly, what I'll talk about, there are more veils, I'll say this, but these are the most common that we encounter. So this one's carbon veil, a little bit more specialty item, a little bit harder to get, a little bit more expensive, and it's also a little hard to work with. But there are benefits to using carbon veil. There are certain instances where you have to use carbon veil, like if you need electrical conductivity, but it's also got excellent temperature resistance. So there are times when you have certain chemicals within your process that when they may react with each other and cause heat to generate via an exothermic reaction. Well, if you have heat buildup, your process temperature might be 150 degrees, but if you have these chemicals reacting and now they're flashing on the inside where they're 180, 190 right on the surface of your vessel, well, you might get some crazing in that area. So in those situations, it may be a good idea to think about using carbon veil. So now we'll transition into basically what chemicals are common for our industry and what veil selection would we recommend. So we're going to just get into that in the next few slides. As a general rule, now don't hold me to it, but just keep in mind the following. This is a chart that I received from Owens Corning. Most people have probably heard of Owens Corning. It's not, don't use it everywhere, but this is just a general helpful guide to know that your very acidic surfaces, you generally use sea glass. When you get to the more basic materials, your caustics, your bleaches, you get more into the Nexus or the synthetic veil. Interesting to note, that kind of dotted line you see of sea glass right around there. That one surprised me, so I had to ask him a few more questions on that. So we'll talk about that on this slide. So mineral acids with your low pHs, those are your hydrochlorics, your sulfuric acids. Those are generally recommended to be C veil. Your organic acids, which quite frankly, we don't come in contact with too many of them. An organic acid would be an acid that has the carbon in there somewhere. So I think it's more in like food services, maybe like citric acid, things like that. Would be an example of an organic acid, in which case you might use an ECR veil. That kind of falls in that mid-range pH to the 4 to 7 range. That doesn't work as well for sea glass. High pH, it's pretty standard. You go with the Nexus veil. Not always, keep in mind, because keep in mind that we didn't even mention carbon veil in this graph, because that's not something that Owens Corning is necessarily worry about. So this was just looking at C glass, ECR glass, and synthetic veil. So what do we need to consider? I already mentioned this before. Temperature is a very big consideration because of the high resin content. You have a lot of expansion, kind of differential expansion between layers when you have a lot of resin versus less resin in a layer. Certain chemicals will exotherm and cause heat to generate. But like I said, if you have a hydrochloric scrubber and you need to neutralize that hydrochloric to get inside with a bleach or a caustic, and then you need to decontaminate, well, now you have 3 different chemicals. It's not just hydrochloric that you're determining what veil you need to use. It's all of those chemicals. So getting a little bit more, I'm not sure how well you can see all of this. I'll dictate a little bit of it, but we're just going to get into some common chemicals that we encounter and talk about which veil would be good, which veil might not be good. So this slide, 10% hydrochloric. I mean, you can have 20%, 30%, that may change it a little bit. So if you have a 30% hydrochloric, we might need to test that. Don't take this chart's word for it on what veil would be recommended. So keep in mind that this is just a comparison of weight loss in various glass types. So this is just glass immersed in these fluids, and it's measuring before and after weight. So what we see here, the C glass has the lowest percentage weight loss, so that would be the ideal glass type for 10% hydrochloric. Carbon veil is also possible. Like I said, carbon veil is not on this chart, but this is just through our research, through our experience. There are situations you could probably substitute a carbon veil. Nexus veils, it's a very acidic, low pH. We just saw that, remember that chart earlier? Low pH, not good for Nexus. This one is 10% sulfuric acid, same chart, same C veil, ideal glass type. I don't know that many people would really get into anything other than C veil, so we don't even need to discuss the other veils. C veil seems to be pretty good for that. When we get into our base material, or caustic, so sodium hydroxide. This was the unique one that was talked about yesterday, where there's certain concentrations of caustic that are better or worse. And Mike Stevens is in the room, and I'm happy for him to speak up too if he has any additional data. Part of what I'm talking about here, so we're Maverick, we do fiberglass every day of the year. If we have questions, if we're not sure, I mean, we still consult the experts, but if we don't know all of this stuff, how can we expect you guys to know it that, maybe only have one FRP project a year or something like that, if you're not in it every day like us, and we're still confused, so we still got to consult the experts too. But this should at least highlight where there's some sort of a gap in information that maybe we can get a little better, maybe we just need to do more research to determine what is really good for certain services or concentrations for that matter. So in this case, for the caustic, this chart would tell you that the Advantex, the ECR glass, ECR veil is a better glass type, and you can see the C glass is way up here, at least for this pH 12.9 at almost 100 C. So the C glass just gets completely eaten up in this case. Carbon veils are also possible for caustic. Like I said, C veils are a poor choice. I think Mike, go ahead, Mike.
Yeah, on the C veil, I actually did a study where I had a C581 coupon and 15% sodium hydroxide at 140 degrees Fahrenheit. And in 7 days, all the C glass fiber was gone, completely dissolved out of the laminate. So, yeah, Nexus is better, but the best veil in sodium hydroxide is carbon veil. That's going to give you your best, especially at higher temperatures. Carbon veil is the best choice.
And a point that was made yesterday, and something to really think about, is, I mean, Mike's doing these C581 coupon tests in a lab in a perfect environment. If you have the ability in your process to put a coupon in your vessel to see how that holds up, I mean, that's going to be the best way, because then that has all of the elements that your process has. So if that coupon is getting eaten up, whereas the lab testing would say it should work fine, well, that tells you have some other constituent elements in your process. So I think what Mike said is note there. So I'm saying that there are differing opinions on the suitability of Nexus based on the research I've done. I think you just stated that Nexus is okay for caustic at certain temperatures, right? So
yeah, ambient temperature up to probably 120 degrees. Nexus double. We always recommend double Nexus, and it works fine.
yeah.
And we got data to back it. But if you're higher than that, I always recommend carbon bell.
Yeah, a general rule that I keep in mind, Nexus over 150 kind of concerns me a little bit. We've seen a lot of grazing out in the field, so Nexus, because it just seems to hold more resin than your C-Vel carbon bell. So just keep that in mind. So this is a note just about the caustic from Nexus. Just in my research, so this is me who knows fiberglass doing research and just finding different things about this stuff. So if you can't read this, so this would be Nexus and sodium hydroxide so various materials. So carbon bale, no sign of attack. That's exactly what Mike just said. Sea glass, totally attacked. Polyester, it says totally dissolved. So, okay, there's a separation of information here. And I'm not, believe me, I'm not putting down Ashland. This is just where, I mean, we're getting better. So don't assume that what's been published 10 or 15 years ago is necessarily what we're talking about today. So in this case, out of Ashland's guides for sodium hydroxide, all concentrations up to 180 degrees, you have this little superscript here, a 1 and a 2. Well, the number 1 says double synthetic veil should be used. We just saw that the synthetic veil was totally dissolved. So if you have a question, ask Mike.
Yeah.
And Mike, go ahead if you want to add something to this.
Yeah, because this is just the pure fiber, no resin.
Mm-hmm.
So I think what you're seeing is in the coupon testing, the Nexus is protected better with the resin than what the sea glass is. The sea glass, the caustic is still getting to it a little better because it's dissolving out the Nexus. We got test data with Nexus showing that after 12 months it's still there and the union is still acceptable on the surface.
Now, correct me if I'm wrong, I believe you told me the other day that you are updating these charts. This is a carryover from
Yes.
the Dow days, that you guys will be updating your charts. So be on the lookout for that Ashland's working to update these to include different concentrations with all the things we're talking about of, greater than or less than 50% of caustic and what veil is really the best selection or what resin is the best selection.
And every few years we review the corrosion guides and update it with the new information we have. So some of the recommendations in the guides may change because we have new information.
Mm-hmm.
And this is the case with the caustic. That's what we're doing currently with the new guide. We're going to be updating it with the most up-to-date information.
Okay.
180 maybe for 10 to 30% is probably too high temperature for it.
So that's great information to know, absolutely. Bleach is another kind of variable veil selection that's out there, sodium hypochlorite. Don't worry about this, AR glass, that's not really in our discussion right now, that's not really for the corrosion world, so we're still talking here. Technically, we're looking at the ECR veil per this chart would be ideal. Again, this is just glass fibers, pure glass fibers, and Nexus veil would also be possible. This is a case where carbon veil and C-Veil are poor choices. There are maybe a slight differing of opinion here too. I know carbon veil, no good. C-Veil I think is up in the air, correct?
Carbon veil will, in the coupon it lasted 30 days. When I pulled the coupon out, there was no carbon fiber left.
Mm-hmm.
Our testing actually showed that C-Veil performed better than Nexus veil in 10 to 15% sodium hypochlorite. Like what we used to
Watch
think.
this next slide. While Nexus is the optimal choice, some testing has shown, that means what you're just talking about, some testing has shown that C-Veils may be used, but there are differing opinions. And there's theories because in a lab, again, a lab setting versus what's really, in the real world, in your processes. Sodium hypochlorite might, if you add a little bit too much water, water's removed, it might change the chemicals around, turn it into something else that could be attacking these veils. So again, if you can put a coupon in your process, that is a much better way.
Which part of the study I did with comparing Nexus to sea glass was coupons in actual storage tanks.
Okay.
And I've got a paper that I've written on that.
Okay.
Showing the data, and when we did the testing at 150 degrees with sodium hypochlorite, after 12 months, the Nexus coupon only had 30% retention of properties, where the sea glass coupons had 70% retention.
Interesting. So there is information available. You have to know who to ask and where to find it. You have to go searching for it sometimes. And this is where I say again, where you see the picture on the right, where we see some crazing of the liner there, a little bit of thermal shock, where if it's over 150 degrees on Nexus, doesn't work very well. So just some pictures, just of what the realities of high temperature effects in these components is. It might be poor veil selection, it might be an excursion temperature that wasn't anticipated, but here it's kind of hard to see, but you can see in your handouts there's a lot of just fine kind of hairline spider cracking with even some open blisters on here. To me, that tells me it's a high resin content. Usually when you have blisters like you see here, or even when you get to here, the blister gets so big that it eventually cracks. That usually means there's air somewhere within the laminate. Hydrochloric will permeate and create blistering. In these cases, poor fabrication will also lead to blisters. You just have a little bit of an air pocket in there. When you heat it up and cool it down, heat it up, cool it down, it's just going to keep going until it gets so big that it breaks open. So shifting gears a little bit, we'll get more into abrasives now. So obviously, some people in the audience use fiberglass for abrasion resistant. If you're transporting slurries, for example, at your power generation plants. Veils alone are not enough. There's differing opinions as to which veils are better. There's studies show that carbon veil has a little bit less volume loss than the other veils. There's opinions out there that says Nexus veil is actually better for abrasion resistance. I haven't seen that testing. If somebody's telling you something, make sure you're getting the test data. Ask for the test data. If they don't show it to you, then it's just opinion, and it shouldn't really make your decision for you. So veils alone are not okay. The two best abrasion-resistant additives that you're going to mix in the resin when you're laying up the corrosion barrier will be the silicon carbide or aluminum oxide. Those are the best proven additives that we have in the industry today. Here are some examples of some abrasion. So abrasion liners are a little bit different from corrosion barriers in that you're making an abrasion liner because you know it's going to erode away over time. Sometimes corrosion barriers last forever. Sulfuric acid might penetrate a corrosion barrier, 20 mil, 20, 30 mils, and then just stop, and now you're good. But abrasion liners are made to wear away. So if you want to extend your life, then you just make your abrasion liner thicker, but eventually it will erode. And sometimes it depends on where it is in the process. Usually right off your pump, that first fitting, that first spool, if you have a reducer spool or something, that first, that's the highest velocity. So usually you see a lot of wear in those areas. And once you start seeing windings, once you get past, because there's not going to be any silicon carbide or aluminum oxide in the structural wall because that would affect the properties. So once you get past your abrasion liner, you got to think about relining or replacement very, very quick because you're losing strength every time you're eroding some of those windings. If you wear enough to go through the entire wall of the riser, I would say you have either you weren't paying enough attention or you have an issue with your process that is focusing on certain areas. But yeah, if you see exposed woven roving, that is not a good sign. That means the liner is gone. Right here would be an area where there was abrasion-resistant material, and now there's not. And upon closer inspection, you can actually see some of the windings are gone there too. And this is another example where you can just see bare windings. This is a case where it's just a discharge off of the pump. What may not be known is salt can also be abrasive, especially when agitated. We found this out very clearly not too long ago, where this was, it's hard to see, but this was around the original look of the liner. And after 5 months in operation, a lot of wearing of the veil. Now, I will say there could be some manufacturing issues that led to this, but I believe the veil, the resin was only selected because of the chemical service, not considering that there is an agitator in there. I mean, after only 5 months, this is very, very substantial, very, very concerning wear. Lastly, you can also make them conductive. So you folks that have chimney liners or ducts that transport gases, the high velocity gases can make friction, generate a static charge that needs to be dissipated because fiberglass alone cannot ground it. So you need to use a carbon veil as your inner surface, which is conductive, but carbon veil alone isn't enough either because you have resin surrounding that. So just bare resin, if it's not conductive, it's not going to make it to the carbon veil and out. So you need to mix in a graphite powder into your resin so that you can maintain that conductivity throughout. So this is an example of what the conductivity test is. You basically have some silver paint on either side, you have a voltmeter, and to see what the resistance across that point is. Either you go from spool to spool or end to end to make sure you meet a certain, you don't want to go over a certain resistance threshold. The picture on the right would just be how a chimney liner would be made conductive through a main joint. So you'll have a lug on the inside that you basically drill through the wall, and then you have to have conductive putty around there to make sure it goes from the carbon veil to the lug to out here, and then eventually it will be grounded, out of the stack. So that's how you make a veil and a corrosion rated conductive. So closing thoughts. Harped on it a few times, but just say it again. Lab experiments versus real world can be completely different. Take your real world understanding, results, over what they will tell you in the lab necessarily. When in doubt, research. Ashland, they'll give you a resin recommendation, they'll give you a veil recommendation if you have any questions. They turn around pretty quick. I bother Mike a lot. And he's very, very helpful, and Mike's not the only one that helps too. Just be aware of subtle process changes. Either repurposing vessels or making a new vessel. Everybody wants to tweak their processes just a little bit, which might introduce a new chemical, new temperature, something else that can affect. So just because you did this before, don't assume you can do it again, because the service life is dependent on a bunch of things: veil selection, resin selection, cure system, post-curing, construction quality. There's a lot of things there, so it's not just veil, it's resin, it's a little bit of everything, which makes FRP so unique in its custom nature. That's why you need to track this process from genesis to completion. So with that, I think we're decent time. Any questions?